Welcome to the chemistry class and hope all of you are well. Today I will continue your organic chemistry part, and now I will discuss the alkenes already completed. Next we will discuss alkenes. All of you know the general formula of alkene is CnH12. This is the general formula of alkene. General formula. Now, if we think about the alkenes are called olefins. Latin word that is the olefiant, that means oil forming. Okay, and because the lower members form oily products on treatment with chlorine or bromine, and the first member of this series when we are putting, because n is equal to 2 is the first member, because for formation of carbon-carbon double bond 2 carbon is required. So this will be C2H4, and this is the structure of ethylene, formula of ethylene. Okay, so this is the first member, okay, of this alkene series. Now first we will discuss the laboratory preparation. Laboratory preparation we can do that we have to take alcohol. If we take ethyl alcohol and if we add concentrated sulfuric acid, and we have to heat around 170 degrees centigrade, then there will be dehydration. Okay, and we will get CH2 double bond CH2 plus H2. So here is elimination of water molecule H2. Okay, actually what is happening, first this OH will be protonated, then there will be loss of proton, formation of carbocation, and finally the elimination of proton will get the alkene. And we can also use here aluminium oxide as a dehydrating agent, and temperature is required around 350 degrees centigrade. So from this alcohol also we can get the alkene, that means from ethanol we will get the ethylene. But if we heat at lower temperature around 140 degrees centigrade, then there will be formation of diethyl ether. Okay, so this temperature is very important. If at higher temperature than 170 degrees centigrade, you will get the alkene. Another process we can tell that the dehydrohalogenation of alkyl halide. Dehydrohalogenation of alkyl halide. Suppose we are taking that CH3, CH2, Cl, and we are giving here alcoholic KOH. Definitely there will be elimination of minus HCl, and you will get the alkene. Here also you can take bromide or iodide. Okay, so alcoholic KOH, there will be elimination, but if you take aqueous KOH, there will be substitution reaction, you will get alcohol. Okay, so here you have to take the alcoholic KOH. So by this process we can prepare the ethylene compounds. Okay, next we will discuss the physical properties. Now what will be the nature of this type of compound? It is a colorless gas with present odor. Okay, and its melting point will be around minus 169 degrees centigrade, as this is a gas, and boiling point will be minus 104 degrees centigrade, and it is insoluble in water but dissolves in organic solvent. It is slightly less denser than air, And next we will discuss the chemical properties. Alkenes are more reactive than alkenes due to presence of the double bond. Now, if we draw the structure, we can already draw structure is given here. We know that sigma bond is formed by head-on overlap and pi bonds are formed by lateral overlap. So here one sigma bond is there, another is pi bond, and this pi bond is weak. So that is why there will be addition reaction. So generally, in case of alkene, there will be addition reaction. First, we can think about that addition of hydrogen in presence of nickel catalyst. So if we take CH2 double bond CH2 and if we give nickel and hydrogen here 1 mole is required, okay, and temperature is required around 300 degrees centigrade. So we will get the ethane. So there will be addition of hydrogen. Next we will discuss that addition of halogen. If we take that ethylene compound, there is double bond. If we add bromine carbon tetrachloride, it is reddish brown in color, and there will be addition of bromine in each carbon atom, and they will form 1,2-dibromoethane, and it will be this bromine color, this reddish brown color will be discharged. In the same way, if we take chlorine carbon tetrachloride, there will be addition of 2-chlorine, 1,2-dichloroethane you will get. Next we will discuss the addition of halogen acid. In your syllabus there is only ethylene, that is why I am discussing only ethylene. So here if you give HCl, one side there will be formation of carbocation after addition of H, and another, then that Cl minus will attach here and you will get that ethyl chloride. But if you take HBr, actually this is symmetrical alkene and you are getting these products. But if you take unsymmetrical alkene, that will be in the higher classes, class 11, then I will discuss. Okay, next there will be the addition of water. That CH2, double bond CH2, when you will add H2O in presence of acid, H plus, then one side there will be addition of hydrogen and another side OH, that means you will get that ethyl alcohol, that will be the addition of water. Next is very important reaction, that is the polymerization reaction. Polymerization reaction. Here n numbers of ethylene will form polyethylene. And all of you know the use of polythene bag. So in this way we can prepare that polythene molecule, and here heat pressure is required, heat pressure and temperature, and oxygen is also required, and temperature will be required around here 670 Kelvin. Okay, so then you will get that polyethylene compound. Next we will discuss that the use of ethylene. Ethylene is used for artificial ripening of wheats. Okay, and it can be also used for anesthetic. Okay, general anesthetic. It can be used for the production of oxyethylene flame. Okay, and the manufacture of polymers like polythene, etc. compounds. Okay, so these are the uses of ethylene. Next we will discuss the another type of hydrocarbon. Okay, these are alkynes. All of you know the general formula, that is CnH2n minus 2. Okay, and here for formation of carbon-carbon triple bond, that means alkyne means triple bond is there, minimum 2 carbon atom is required. So here you have to put 2 here. If you put, we will get H equal to 2. So the simplest and the first member of this alkene series is this compound. This one IPAC name is ethyne and its common name is acetylene. Okay. Now, acetylene does not occur in free state in nature. Traces of acetylene are present in coal gas. Next, we will discuss its laboratory preparation. Laboratory preparation, all of you know, preparation, we have to take calcium carbide. If we add water, then there will be formation of acetylene. So calcium carbide, we are adding water, there will be formation of acetylene and formation of calcium hydroxide. Okay. Here number of hydrogens is 2 and here 2. There we have to give 2 here. Now it is okay. Okay. Now how to prepare this calcium carbide? We have to take calcium oxide and carbon. Then you have to apply heat around 2000 degrees centigrade. Then there will be formation of calcium carbide and carbon oxide. In this way you will get calcium carbide. Another method is there that if you take 1,2-dibromoethyl, first you have to give the alcoholic KOH and heat. Then there will be elimination of HBr and you will get the vinyl bromide. And in the second step you have to give sodamide in liquid ammonia. Then again another HBr will be eliminated and you will get the acetylene molecule. So in this way also you can prepare the acetylene. This is another method by which you can prepare acetylene. Next we will discuss the physical properties. So it is a colorless gas with faint garlic odor, and acetylene is very slightly soluble in water and it is soluble in organic solvents. Okay, you can think about benzene, alcohol, acetone, ether, etc. And acetylene is slightly lighter than air. Next we will discuss its chemical properties. Acetylene is highly reactive due to the presence of a triple bond. In case of acetylene, there is 1 sigma bond and 2 pi bond. And because of presence of 2 pi bond, it is more reactive compared to the ethylene. Ethylene only 1 pi bond is there. Okay. Now here also as pi bond is there, so it will take part in the addition reaction. So first we will show you the hydrogenation reaction, hydrogen addition reaction. So if you take that acetylene, first if you give 1 mole in presence of nickel around 300 degrees centigrade, then there will be formation of ethylene. Then again 1 mole again hydrogen addition will be there because 1 pi bond is still there. So finally you will get that ethylene, and here temperature 300 degrees centigrade, and finally you will get the ethane. Okay, so it will react with this 2 moles of the hydrogens, or directly you can use here 2 moles hydrogen. 2 moles hydrogen in presence of nickel catalyst, or you can use palladium, platinum, okay, this type of catalyst, rhodium you can use. Okay, finally directly here you will get the ethane molecule, CH3CH3. Okay. Next, halogenation, that means halogen addition. So here also it will react with bromine carbon tetrachloride, but as there is triple bond, it will react with 2 mole, okay, of bromine. First bromine CCl2 Br2, CCl4 will react, formation of 1,2-dibromoethane. Again there will be 1 mole bromine addition because still there is 1 pi bond left. Then you will get tetrabromoethane. This one is 1122, okay, 1122 tetrabromoethane. So this type of compound you will get. In case of chlorine carbon tetrachloride also there will be addition of 2 mole chlorine, and you will get that 1122 tetrachloroethane. Next, in case of addition of halogen acid, So whenever we are adding HCl, one side there will be addition of hydrogen and another side Cl. In the second step, when again we will add HCl in the same side, you will get this type of compound. So this is 1,1 dichloroethane that you will get. Okay. Actually here, if you know the mechanism, then you can understand the stability of carbocation is prepared here. Okay. So according to the stability of carbocation, the nucleophile will attack. That you will learn in higher classes. So these are the halogenation reaction, and next we can discuss that the combustion reaction. Okay. Acetylene burns in air and it will burn with a sooty flame. It will, as it is a hydrocarbon, it will form carbon dioxide and water. So acetylene will react with oxygen forming carbon dioxide plus H2, and plus there will be formation of heat. Okay, and there will be formation of sooty flames. Okay, and acetylene burns in pure oxygen, producing a very hot flame which produces a very high temperature, around 3000 degrees centigrade, and this flame is called that oxyacetylene flame and generally used for welding purposes. Okay, and here this thing should be balanced. So here you have to put 2 here. If you put 5 here, then here we put 4, and here also we put 2. Now it is balanced. Now it is balanced. Okay. Next, another important reaction is there. If you pass acetylene gas through a hot copper tube around 600 degrees centigrade, then there will be formation of an aromatic compound, the benzene will be formed. So this is one type of polymerization reaction. So size C2H2, when it is reacting with hot copper tube 600 degrees centigrade, then there will be formation of a benzene ring. Okay. So in this way we can prepare one aromatic compound from an aliphatic compound. Hope you can understand. Next, we will discuss the identification test of acetylene. These acetylenic hydrogens are acidic. Okay, after releasing this negative charge will be stabilized by that sp hybridized carbon atom. Okay, and that is why if you treat acetylene with ammonical Q plus chloride, okay, then there will be formation of red PBT of Q plus acetylite. Okay, and by this way you can easily identify that there is acetylene. And another you can do that if you take that ammonical silver nitrate solution, definitely there will be formation of silver acetylite, white PBT. Okay, and by this way also you can easily identify the acetylene. So one is that Cu C111C Cu. This one is the copper acetylite. It is red in color. It will be precipitate. Okay, red PBT. And silver acetylite formula is like this. The silver acetylite, white PBT. So by these two reactions you can easily identify the acetylene. So from alkynes only acetylene is in your syllabus. Okay, and so next is there carboxylic acid and alcohols. Now these are excluded your syllabus. Okay, because of this pandemic situation, so they are not in syllabus. So in this way we have completed your organic chemistry part, and next day we will discuss some important questions from this chapter. So today up to this, thank you.